All right, folks. Today we're going to be taking some notes. So if you don't already, please get out your math notebook and flip to a fresh sheet. As you're watching this video, you can always pause it if you need to get caught up, or you can rewind it if you do need to listen to something again. So utilize those features. I'm going to go ahead and share my screen. That's the cheat sheet. We're going to do that today. Okay, so we are going to be talking about rates, ratios, and unit rates. And today is the first, 12-1. All right. Let's talk about that ratio. What is a ratio? These notes today should be somewhat familiar. We did talk about these last year in 6th grade, although we were online, so I'm interested to see how much of it stuck. But it is going to be a good review for most of you. A ratio is a comparison of two quantities. A comparison of two quantities. Okay, so pretty basic. We're going to get into a bunch of examples here. First one, we're going to deal with some shapes. So we've got 2 circles. We've got 3 triangles, all different shapes. And we're going to do 4 squares. Okay, so now we've got a way using ratios that we're going to compare the number of these shapes. There's 2 ways that we can do this. We can do this part to part. So say I wanted to do squares to circles. So the whole would be this whole thing. That's going to come next, but we're just looking at the different parts here. So I've got 1, 2, 3, 4 squares. And I'm going to write 2. We get into how we can write our ratios in a second. So I've got squares, 2 circles. I got 4 squares. And how many circles? I got 1, 2 circles. So that ratio is just 4 to 2. So another way we can say that is for every 4 squares, there are 2 circles. Cool. Some other ways that we can write this is we can use a colon, 4:2, or we can write these ratios in fractional form as 4/2. All of these, though, we say 2 in between, 4 to 2, 4 to 2, 4 to 2. Cool. So that's part to part. That's just an example. And we can also say part to whole. So another way we can say that is triangles, our first example, to total shapes. So how many triangles do we have? We've got 1, 2, 3. And what's the total amount of shapes? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total shapes. So 9 there. 3 to 9 triangles to total shapes. And we can also write that as, I kind of went out of order here, but that's fine compared to over here. 3 to 9. Or I can write it in fractional form, 3/9. Those all represent the same ratio, regardless of how we write that. Yeah. So again, there's 3 different ways we can write our ratios. And I'm going to say another big point is order counts. And the numbers in a ratio are called terms. So the terms of this first ratio here are 4 and 2. The terms in this ratio are 3 to 9. And I do say that order counts, right? It says squares to circles, not circles to squares. So if you write it as that ratio, that's going to differentiate what you're talking about. So make sure you're following the order that is given there. Yeah, and again, the numbers are called terms. Cool. That is our little spiel on ratios. Let's move on to rates. And again, if you need to go back and get caught up, please do that now. But I'm going to try to keep this video as short as possible. So I'm going to keep moving. So now we're going to talk about rates and unit rates. Okay. Rate is a ratio that relates quantities with different units. Okay, so when we think of rates, we're thinking of ratios with units. Let's think about a jar of peanut butter. There's my jar of peanut butter. And at the store, it costs $3.30 for a 16-ounce jar. So let's say that jar is 16 ounces. So here's my first rate. And again, it's a ratio with units, and they've got different units here. Up here, I've got dollars. Down here, I've got ounces. So if I wanted to write that out, I could say that's $3.30 for 16 ounces. Cool. Let's split this down the middle. And now we're going to talk about unit rates. And a unit rate relates a quantity to one, I'm going to box that out, unit of another quantity. So let's say, so that one is going to be super important, right? Over here, we're dealing with numbers greater than 1, 16 ounces. But now we're going to talk about one, what one unit costs. Let me show you what I'm talking about. We're going to take another jar of peanut butter. This one's a little bit different. Peanut butter. And this one's going to cost $8.60 for a jar that's 64 ounces. Now, what I've done here is just the same thing over here. This is just a rate because it has 2 different units, dollar signs and ounces. But what's going to make it a unit rate is I'm going to set up a separate ratio. Sorry, kind of running out of room here. But here's where the 1 ounce is going to come into play. Over here we had 64, but I want to know what 1 ounce cost. So that's going to leave me with X dollars. And that's where we're going to start talking about next, is if we know that 64 ounces cost $8.60, how much is 1 ounce going to cost? And that's what we're going to be talking about next. So this ratio, whatever we get for the X, is going to be a unit rate because it has to do with 1 unit. In this case, it's ounces. Now, unit rates are super important, super useful in the real world when we're talking about which one is the better buy. If let's say what we're going to do is we have 1 jar of peanut butter that's $3.30 for 16 ounces, another that's $8.60 for 8.60 for 64 ounces. Which one is the better buy? Now this one's more expensive, but we get more ounces of peanut butter. This one's cheaper, but we get less. So when they're differentiated in that way, we need to figure out the unit rate. How much does 1 ounce of that peanut butter cost in each scenario? And the lower cost is going to be our better buy. So it's going to be a big thing we're working on now. So I'm going to move on. If you need to get caught up, please do. I'm going to keep going. So which is the better buy? So we're going to use our examples up here and figure out which of these is the better buy. First thing we're going to do is write down that rate. So $3.30 over 16 ounces. Now I include my units to make sure that everything's in line, which you guys need to do as well. When we're talking about rates and unit rates, units are super important. So again, when we're talking about unit rates, we're talking about what 1 unit is. In this case, it's going to be ounces. We're not interested in what $1 is. We're interested in how much 1 ounce cost. So I need to figure out that X, the cost. The variable in this case is the unknown number, and we need to figure that out. What we need to do here is look at the relationship between these two numbers. How am I going to get from 16 to 1 using a multiplication or division? Well, I know that if I divide 16 by itself, I'm going to get back to that 1. So there's my relationship here. Division, dividing by 16. And I'm going to apply that same relationship to my numerator to get that X. Okay, so I'm paring this down from 16 to 1 by dividing that 16 by itself. So this is going to become a division problem. Where I need to do some long division. Now, always that first number goes inside the box because I got $3.30 divided by 16. So that $3.30 is going in the box and the 16 is going out. I'm going to do my little placeholders. If there is not a decimal in the divisor, I don't need to move my decimal place at all. I can just pop it up from where it started. And now I'm ready to divide. Does 16 go into 3? No, it does not. So I move 1 over. Does 16 go into 33? It does. 2 times. 2 times 16 is 32. Subtract 1. 1's less than 16. We're good. Bring down is my final step. And now I do the process all over again. Does 16 go into 10? It does not. So it goes in 0 times. And I'm going to then multiply 0 times 16 is 0. Running out of room. I'm going to subtract. And I'm going to bring down, I'm going to add another 0 because you'll notice that here's my decimal point here. Here's the 10th place. Here's the 100th place. So that's all I really need to go when I'm talking about money. but I want to do so. I might need to do some rounding. I'm going to in this problem. So I'm going to go one further in the thousandths place, bring down that 0. 16 goes into 100. How many times? Let's guess 6 times. Good. Okay, so I'm going to put my 6 here. So I went, how many times does 16 go into 100? It goes in 6 times. And I'm just going to leave that there because that's all the numbers I need to round to the nearest cent here. So my cent is right here in my hundreds place. So if I were to round, I look next door, it's 5 or more. So I'm going to let that 0 soar. So this X is going to be worth 21 cents. So for every 1 ounce, it costs 21 cents. So there's my unit rate for that first example of peanut butter there. Okay. And we're going to do the same thing now to what we had up here. So we got our unit rate for this one. Now we're going to find the unit rate for this one. And we already set it up in this way. So I'm just going to copy that back down. So I got $8.60 for 64 ounces. And I need to figure out what 1 ounce is and solve for X, that unknown. Now, again, I'm always looking for the relationship in my denominators. How can I get from 64 to 1? And remember, when we're doing this, we're only using multiplication or division, not adding, subtracting. It doesn't work in this case. I know that if I divide 64 by itself, I get to 1. So really for all of these unit rate problems, you're basically dividing by that, whatever is in that denominator in the original rate. Once I find that relationship of dividing by 64, I'm going to apply it to the same thing up here, 64. And now I just need to do some division. And again, $8.60 divided by 64. That first number always goes inside the box. I'm going to add another 0 because I know that I'm going to round to the nearest cent. 64 goes on the outside. My footprints go over top. And since I don't have to move my decimal place over, it's just going to pop up where it is there. Okay. Now we're ready to divide. 64 doesn't go into 8. Move it over. How many times does 64 go into 86? Well, that only goes in 1 time because 64 doubled would bring me over 86. So 1 times 64 is 64. Subtract. I'm going to get 22. 22 is less than 64. We're good. Now we're going to bring it down. And now I repeat the process. How many times does 64 go into 220? I'm going to guess 3 times. Let's check. 12, 1, 18, 19. Yep, that's pretty close. Not going to get any higher than that. So 3. 3 times 64 is 192. Subtract. And after some borrowing action, I'm going to get 28. And then 28 is less than 64. We're good. Let's bring that 0 down. How many times does 64 go into 280? Well, I just guessed that 64 times 3 is 192. We could probably bump that up one more time to 4. And I'm going to get 4 times 4 is 16, 1, 24, 25. Yep, that's pretty good. So I'm going to say 4 here. And I'm just going to stop there because, again, all I need to do is reach that thousands place in order to round to the nearest cent. To round to the nearest cent, I look next door. It's 4 or less. So I'm going to let that 3 rest. So my answer for X is 0 and 13 cents. So now I've got the two numbers to compare. Over here, it's 21 cents for 1 ounce of peanut butter. Over here, it's 13 cents for 1 ounce of peanut butter. So this guy is the winner. This one is the better buy. It's the cheapest. So better buy. Kind of squeeze everything in there. Sorry, guys. But this is the one here. Cool. And that's it. Thanks for your attention. As always, you can rewind, watch this over again, pause, and get caught up on the notes. Thanks for watching. Bye-bye.